Hello and welcome back everyone to this series of videos where we're making a game in JavaScript that's going to look like this. So in the last video, we ended up being able to define our levels inside a JSON file. Now this is a pretty ugly and tedious way of creating a level. So this episode is all about building a level editor for our game that you can see on the screen now. So we're going to add the ability to select tiles from the tile set and paint them onto the map. And we will also add the ability to take objects and put them on top of the map. And the end result of all this is we're going to be able to make more exciting looking levels for our game. So let's get started and write some code. So the first thing that we want to do is add a tile picker to the document so the user can select the tile they want to use. So let's go ahead and add a new canvas element called tile picker canvas. We'll make it 512 by 512 pixels in size, which is enough to hold 256 of our 32 by 32 tiles. Also note that we add the editor class to the tag. This will be useful in a second. Now we'll want a way to turn the editor on and off, and since we are making our game on a web page anyway, let's go ahead and use a URL parameter to do that. So we can write some code that looks like this. What this code does is it looks for the editor URL param, and will hide any tags with the editor class when the parameter is not true. We do this by adding the styling display none. Next up, let's add a new file called editor.js to contain all the logic for our editor. First, let's draw the tile picker. Let's start by drawing the tile set itself. Then, let's also add a loop to draw some horizontal and vertical lines to give the user a visual cue as to the boundaries of the individual tiles. Note we can do this in one loop since the tile picker is a square. Now, back to the main game draw function, let's add a little logic to only call the editor.draw function when the editor is actually enabled. Let's go ahead and give that a try. Alright, looking good so far. Note that we have the editor URL param set, and we can indeed see the tile picker with the grid as we expect. As the user hovers over the tile picker, it would be nice to highlight the selected tile. To do this, we will need to capture the state of the mouse. We can do this easily enough. Back in our input.js file, let's create a new global called mouse to capture the state of the mouse. We'll have an x and y coordinate and a boolean called down that keeps track if the user has the mouse button down. And once again, we just need to listen to a few mouse events to capture the state of the mouse. We'll use the mouse move event to update the x and y values, and use the mouse down and mouse up events to keep the down value updated. Okay, so let's just take a little break from coding for a minute to talk about coordinate systems, because we actually have three different systems we need to work with here. First, we have the x and y coordinates we got from the mouse move event. These coordinates are viewport coordinates from the browser's viewport. However, what we really want to know is where the mouse is relative to the tile picker canvas. We will call these the canvas coordinates. Finally, we want to convert these into our own coordinate system that we use for the tile set, our tile coordinates, which look like this. Tiles are given x and y coordinates in hexadecimal from 0 to f, 1 digit for x and 1 digit for y. So what we want to convert from is this to this to this. Got it? Alright, so with all that explained, let's go ahead and write a function to get the tile coordinate that is under the mouse cursor. First, we want to convert from the viewport coordinates to the canvas coordinates. Turns out this is pretty simple. We just subtract the canvas offset left and offset top properties from the x and y mouse coordinates respectively. Next, we do a test to see if the mouse pointer is actually over the canvas. If so, then we convert to the tile coordinates by simply dividing the canvas x and y coordinates by tile size, which remember is 32. If the mouse is outside of the canvas, just return null. So, if we do go back a tile coordinate from our new function, then we will want to draw a box around the selected tile. This turns out to be pretty trivial. We can use the canvas stroke rect function to draw an empty box. We give it the x and y starting positions by multiplying the tile coordinates by tile size. And the box is of course tile size in width and height. And doing a quick test, we can see that it works. Now we want to test if the user has the mouse button down, and if so, we will store the selected tile in the property on the editor object. We need a bit of logic here to go through the tile objects in the level and find the matching tile. Note that we are still hard-coding level 1 as the level object just for now. And with a little console logging, we can see that our tile picker is working. Next, we want to let the user plonk the tile they just picked down on the map. First, let's start by highlighting the selected tile on the map when the user hovers over it. We can reuse the code we just wrote to do this, but this time on the game canvas. And here we can see this working. Not sure why I decided to use red for highlight on the map and green for the highlight on the picker. It seemed like a good idea at the time. So we have the tile the user has picked, and we have the location where they want to place the tile on the map. So now we just need to update the actual map array in the level when the user clicks the mouse button. And with a little coding and debugging, here we go. Looks like it's working. We can start creating levels in our new level editor. Now before we get carried away designing levels, we have a few more things we need to take care of. If you remember in the last episode, we manually entered the details for the tiles, but only for a few of them, since it was quite tedious. Now that we have a tile picker, we can solve this problem by adding a form that will let us enter or update the details for the selected tile. Firstly, I thought it would be a nice touch to actually show the selected tile. We can add yet another canvas in our document for this. We will copy the selected tile onto the canvas in the same way we have done a few times now, but with the difference that we will blow the tile up and make it 2x bigger in each dimension when we copy it onto the new canvas, so we can get a good look at it. There we go. Now things get a little weird when we try selecting the objects. It's because they have an alpha channel on them. Let's make sure we redraw the background on the canvas first before we draw the tile onto it. Alright, that looks a little better. Let's get back to updating the details for the tile. Let's go back into the HTML file and add a form for the tile details. We will want a text field for the tile description and checkboxes for the Boolean properties that indicate if the tile is passable and indicate if the tile is an object. We can add an event handler to override the default form submission behavior and instead update the tile details in the level object. Okay, so we are so close in our level editor, but there is one last problem. Right now, we are only updating the level 1 object that we have hard-coded into the game. This means any hard work we put into creating a level will be lost when we refresh the browser. What a disaster! So we need to create one final form. This will allow us to take the level and save it as a JSON file. This is one of the nice things about working with JavaScript. You get JSON serialization basically for free. Let's also add the ability to load the file from JSON while we're at it. Alright, so with a little more coding and debugging, we can see that this seems to be working. We can update the map and the tile details, and we can save and load this data into a JSON file. Nice. So now that I can save my work, I went ahead and filled in the details for each of the tiles, giving each tile a name and indicating if it was passable and if it was an object. This was a bit slow and tedious, but now that I can save my work, I will only have to do it once. And now finally the fun part, I get to build a proper level for the game. Didn't have much of a plan here, the general concept was just a couple of caverns connected together. Alright, so this is starting to look like a proper level. I'm having some fun mucking about with the editor, and I have some ideas for some more levels. But what about these object tiles I keep mentioning? We're going to need them as well for a proper level. We could treat them like any other tile and place them in the map, but that's not really what we want. What we really want is to draw them on top of the map tiles. So we'll need to keep them in a different data structure to the map itself. we could introduce a new 2D array to hold the objects. And that seems a bit wasteful since the array would be mostly empty. Also, conceivably, we might want to place objects on top of each other. So we ended up with this. In the level, we have an array called objects, and each object stores both its ID and its x and y coordinates. This is opposed to the map, where the x and y coordinates are inferred from the tile's order in the array. So now when the user plonks down a tile, we just need to test if it's an object, and if so, put it in the object array instead of in the map. We also need to set the x and y coordinates, of course. And when we draw the map, we'll need to add some new code to loop through the objects and draw them in the correct location on top of the map. Okay, so let's try this out. At first, this seems to work, but wait a second. Let's zoom in and take a closer look. Remember I mentioned the objects have some transparency? Well, see the shadow under this diamond? It should not be totally black, but actually partially transparent. Same goes for this white light. It shouldn't be solid white like this. So what has gone wrong? Well, you might think the problem has something to do with the way we draw the image onto the canvas. But actually it has nothing to do with that at all. The real problem is actually with how we handle user input in the editor. Remember that in the editor, we check if the mouse button is down when the user hovers over the map, and if so, we call the update map function to update the tile at that coordinate. But remember, we're doing this on every frame. So if the user holds the mouse button down for say half a second, and we are rendering at 60 frames per second, then we're going to call update map 30 times. This is actually fine for the map tiles, because we just end up updating the same location in the map 30 times. Yeah, it's a little inefficient, but it doesn't actually cause any real problems. On the other hand, for the object tiles, instead of updating the same tile 30 times, we end up adding 30 objects to the array. This is clearly not what we want. The transparency disappearing from the object is actually just a side effect of drawing the same object over and over again on top of itself. Obviously, what we really want is to update the tile only once per click. Fortunately, there is a simple, elegant solution for this. We can use some edge detection and only update the tile when the user releases the mouse button. So let's go ahead and add a property to the editor object called mouse down. This will record the state of the mouse button from the last frame. We will then compare the current state of the mouse button to the state from the last frame. If the mouse button was down last frame, and now it's up, then we've detected that the mouse was released and the user has completed the click. And only when this condition happens will we actually update the tile. And let's try it out, and there we go. Our objects have some transparency again. Great. Okay, so we're nearly done with the editor, but there is one last thing I wanted to add. That's the delete button. You might have noticed this slightly ugly icon that I added to the tile set. The idea here is we will treat this tile as a special case that can be used to delete other tiles. I decided the way this should work is when you click on the map with the delete tile selected, it will first check for any objects at that location and delete them from the objects array. If there are no objects found, then it will instead replace the tile at that location on the map with a special blank tile. And here we can see it in action. We can delete objects, and then we can delete the map tile under the object. Note that if we have multiple objects stacked on top of each other, it will delete all of them in one go. I think this is a reasonable behavior. Okay, so now we're really done with our slightly ugly but very functional level editor. I was having a lot of fun making levels and went ahead and created another one that looks like this. It's a bit of a different style. Okay, so we've covered a lot. I think it's time to wrap up this video. But make sure to subscribe so you won't miss the next episode where we're going to make collision detection work. See you next time.